Good morning, everybody. I'm just going to kick straight off. Today, we're going to talk about drip tray overflows, and not so much the drip trays themselves, but and where to put drip trays, etc., but the overflow pipes, because there's a lot of differing, should we say, opinions out there. And I mean, it's just a little sort of a cliche, but too many cooks tend to spoil the broth. And if we've each got our own set of ingredients in mind, we've each got our own set of circumstance, whatever, and we all add to the same pot, it just becomes an absolutely confusing green, fishy, tomatoey, bubbly, oniony, oxoey thing there, like you can see. Okay, so because I'm sure you'd agree with me, you can go and have 3 or 4 conversations in a day, one at local supplier, one at a job site, and you'll hear differing opinions, like a drip tray overflow can't be longer than 4 meters. Or example, there can't be 90-degree bends. You're only allowed 45-degree bends in a drip tray overflow, because that's people read into conventional overflows, TP discharge pipes, etc., and then they transpose that onto drip trays. Or you'll hear somebody say you're only allowed 50 mil pipe. Now, I'm going to make myself just very clear here. If you don't put 90-degree bends and only use 50 mil pipe, you are doing an absolutely sterling job. But from an auditing perspective, when an auditor looks at a drip tray overflow and he sees a 90-degree bend, if it's failed, which there must be something to go back to defend it on the standards. So I decided a while ago actually to do a little bit of an experiment with all kinds of configurations of drip tray overflows, and this is what I came up with. So let's just start off and see what the standards require, because that's first and foremost. You can't go against what the standards require, no matter what my experiments showed. The standards are there, and you cannot transgress those. So what do the standards say? So SANS 10254 5.1.2.2, the 3 dots means that there was something prior, which I didn't include in this, but so this just continues. The discharge pipe shall be sized, laid out, and supported to comply with SANS 10252-1 and 10252-2. So I'm going to just stop there, get my laser pointer. So immediately we can see that 10254 as the Giza installation standard is not giving us too much detail about how to install the drip tray overflow pipe, right? Because it immediately refers us to 2 other standards, 0252-1 and /2. /1 is the piping layout sort of Bible, I like to call it, for domestic systems, and that talks about brackets and that sort of thing. And 0252 is drainage. /2, I beg your pardon, is drainage. So drainage will talk to us about what sort of materials, what sort of pipes are acceptable. In other words, we need to know 0252-1 and /2 in order to determine what to do with the drip tray overflow pipe. But it continues, and on the next slide you'll see. So just to say that 0252-1 in table 22, which is right at the back in section 8, it talks about PVC waste pipe. I think it's between 32 and 50, but that includes 40 and 50. It requires a maximum spacing between holder bats of 1 meter. So there already it says to us, okay, hang on. 10254 says I must comply with 0252. What does it say about brackets? Maximum 1 meter. Boom, done. So that's the first thing. Then, of course, you look at changes of direction, and so now you can start to defend 6 90-degree bends, because that's too many, so that is all there. But the facts are that you got to comply with a number of standards. 10254 continues to say about the sizing, gradient, and length. Now, this is important because this is what we all argue about. The sizing, gradient, and length of the discharge pipe shall be calculated for a flow rate of at least 40 liters per minute and shall be installed at a gradient of at least 1 in 100. So it's giving you a minimum gradient, minimum fall. So you may not install it at less than that fall, period. But you must also ensure that it is able to discharge at least 40 liters per minute. So this is the sort of criteria, or this is the thing that I took forward and I did a whole bunch of tests with, and we'll see. So what do we know? We know that we need to use a proper pipe, a pipe that is approved or is considered a drainage pipe, a proper acceptable drainage pipe. For example, galvanized mild steel, and I'm taking this verbatim from what 0252 says. Galvanized mild steel, copper, PVC, polyethylene, high density polyethylene, etc. There's a couple of others, but that's pretty much what we're allowed to use. So we cannot use irrigation pipe. We cannot use hose pipe. You know, it's got to be a proper pipe. It is what's the word I'm searching for? It is governed in that the requirement is that we use a proper pipe as if it were a drainage installation, which of course it is, okay? But it must also be supported correctly, as in 10252/1, and we've already established that minimum, I beg your pardon, maximum distance between holdbats is 1 meter. So you have a look at this. That's probably problematic, one would say. Yeah, it's the right pipe, but it's problematic in the sense that it's got no support. The tray must be big enough. These are our other requirements within 10254. It must be big enough to cover all the pertinences as well as the geyser itself. The tray must be sloped towards the outlet. The discharge must go outside and must be visible. And the tray must be supported correctly with the correct timber, etc., etc. So those are just a couple of other notes that we know about. So the question is, how do we achieve this 40 liters a minute? This is like the elusive 40 liters per minute. How do we know what 40 liters per minute is? How do we achieve it, etc.? So what I hope to achieve today is just to open, I don't want to sound, just to show you what different circumstances look like at 40 liters a minute, okay, in terms of pipe configuration, because that's what I set out to achieve, is to try and see what is able to achieve that discharge rate and what is not able to achieve that discharge rate. So let's go back to 10254. It says there must be a flow rate of 40 liters a minute and the fall at least 1 in 100. So how do we achieve this? Okay, so what follows is a whole bunch of pictures, and I've grouped them into little stages. Okay, so here you can see the tray has not even got an outlet attachment in it. By the way, to achieve 40 liters a minute, it's not easy, I want to tell you, because in some of these pictures you'll see my friend standing with 2 hose pipes into this tray. The one hose pipe comes from my mains, directly from my mains. Granted, it's an oldish house and the mains are 1/2 inch. But the other hose pipe comes from my tank and booster pump. So I had to switch both on, and I had to throttle the mains just ever so slightly to achieve 40 liters a minute. And you can measure 40 liters a minute quite easily through a 10 or 20 liter drum, time how long it takes to fill up, and you do your calculations from there. So I can tell you that the flow rate into this tray at all times was in fact 40 liters a minute. I will also tell you that, and this has got nothing to do with what the standards say, but I can tell you that 40 liters a minute is a lot, and the tray needs to do a lot of work, or the discharge needs to do a lot of work to get rid of 40 liters a minute. You can see the sort of flows we're talking about here. So anyway, this is a tray without even an attachment in, just the tray itself, and you can see that it's 3/4 full. So it only just managed to discharge 40 liters a minute. So even the tray itself struggles to discharge. No, it's not struggling, it's only just there. Okay, so now you put the attachment in, and same thing, it filled up even a little bit more, you can see there. So whether or not that attachment throttled it just a little bit, I'm not sure, but it filled up even just a little bit more. It's now at the top lip of that tray. This is 40 liters a minute coming in, and it's struggling to discharge, but it is discharging. Right, now we put a short 50 mil PVC pipe on at a reasonable fall. The tray, you can see, has got a fall on it. The pipe has got a slight fall on it. It's a straight pipe, straight out. The back of the tray there is empty-ish, right? Sort of, it's okay. The front of the tray being lower, it's going, it's discharging. There's nothing running back over the tray, but it's not what I would call comfortable, okay? 50 mil pipe, one bend. So one would think that as the installations become more and more complicated with additional bends, etc., that the water would want to not drain out, be more and more reluctant to drain out. But just bear with me. So you can see that this, on the bottom left-hand picture here, this outlet immediately from the tray to this first bend, that has got a slight backfall, and you could probably call it level / slight backfall. The pipe itself has got a decent fall. So the tray is beautifully got a fall on it. The pipe has got a fall on it, but this 100 millimeter piece here, it's got a slight backfall, or almost, you could almost call it level. Now, just that little section of no fall there caused this tray to back up like that. And you'll see why I say that in a minute. Yes, it's discharging. It's only just discharging at 40 liters a minute, but it's struggling. That's with one bend. Here's another little configuration. Medium pipe, in other words, the medium length of pipe. It's a little bit longer than the first couple. There's still 50 millimeter pipe. There's multiple bends. In this case, they're all 45s, and you can see there's two different configurations there. The fall, though, I made sure that right from the get-go, from the outlet, even the bends, that configuration, it's all got a fall, and it's all sloping towards the outlet. So the fall starts right from the outlet. And look at the level of that tray. It's empty. This is 40 liters a minute. I can tell you that that's a lot of water. And that tray is empty. As it comes into the tray, it disappears. And what I found was that never mind the configuration of the piping, if I had a fall right from the get-go and continued outwards, I had a vortex effect, and I had the tray actually, or the discharge pipe actually sucking the water down into it once it had started to flow. Here's a 40 mil pipe, straight out, medium length. I'd say, what's that, about 4 meters? Slight belly in the pipe. There's that belly. You can see it there between the chair and the tray. So if you were to measure the fall between the outlet of the tray and the outlet of the pipe, there would be a fall. It would be lower than the outlet of the tray, because that's what you hear all the time. Yeah, but there's a fall. The outlet is lower than the tray. Yeah, but there's a belly in the pipe. Now look what happens with a belly in the pipe. It overflows all over the place. It couldn't hope to discharge 40 liters a minute. So that's a straight piece of pipe all of a sudden. No bends, 40 mil. Now we've reduced size to 40 mil. Okay, let's carry on and see what happened. 40 mil, one bend. Good fall. Check that fall. Straight from the get-go, there's a fall. The length of the pipe, I must admit, in retrospect, I see from these pictures, it looks like it's almost not such a lack of fall, but there must have been a significant or sufficient fall, because in this occasion, you can see that the tray easily discharged the 40 liters a minute. Now, this is the same length of 40 mil pipe and with a 90-degree bend, but it's just got a fall, and it's easily discharging 40 liters a minute, where in the slide beforehand, with a straight piece of pipe out, you can see it struggled. It in fact overflowed. So there's a massive difference in flow between pipes with a fall and pipes without a fall, and that's the crux of the matter that I'm getting to. So here's another configuration. This is now 40 millimeter pipe. So we've dropped down in size to 40 mil pipe. Don't worry about those bricks. It's just to keep the tray in place. All manner of bends. Look at the funny bends that I put up there, all backflow and not backflow, but sort of backing up upon itself, and 90-degree bends and funny, and it easily discharged 40 liters a minute. because it had a fall. Every part of it had a fall, straight from the get-go, boom, out, round that funny S bend, round a 90-degree bend, no problem. 40 mil pipe, because it had a fall. And that's the message that I want to get across today, is that if you've got a fall on a discharge pipe, the tray discharge pipe, you're golden. But the minute you've got a belly or a slight flat piece or a slight backfall, even right at the end, or and guys, how do we achieve this? It's a very simple thing. Now, please, I'm not talking about the installation of a tray holistically. In other words, you need supports, and we're not talking about all those details. I'm simply talking about, and I'm narrowing it down to the fall of the discharge pipe from the tray. So how do we achieve that? We've got to lift the tray enough to create a fall. That's number one. How many installations do we come across where you'd ask to replace a geyser, but you haven't really checked how much fall you need for the drip tray pipe, so you replace the geyser on the same supports that were there, only to find that you have to put your tray discharge pipe level because there's not enough fall. So please lift your tray when you're replacing a geyser or when you're installing a geyser. In other words, build the platform up. It's got to. This is the point. If the tray is lifted up high enough, you can create a fall. But it still doesn't get you out of the woods, because you still got to ensure that the drip tray overflow pipe is supported correctly. If you put a 4 meter length of pipe with one bracket in the middle, it's not going to suffice. You're going to have a belly, or whatever the case may be. As soon as you have a belly, as soon as you have a backfall, that's a problem. So that's what I wanted to, that's my point that I wanted to get across today, is the imperative thing is the fall. Yes, there's good practice about minimum changes of direction, only 45-degree bends, but as you can clearly see, 90-degree bends don't. It's not to say that it's a failure. It works because I'm complying to the standards. I'm saying that the standards require me to discharge at 40 liters a minute, and I am doing so. But I'm doing so through proper design and fall.